All right, so in this video, we're going to see how we can pass functions around mainly to other functions. So basically, a function can return a function, just like a function can return a variable or a value rather. A function can also return a function. So here is an example. We have our get function that defines the add function inside. Add simply adds two elements and returns the sum, and then the initial function returns the add, okay, to whoever it calls it. So we have our add function equals get function, and then we use it to calculate the sum of two variables, two values. So let's try that out in our code. So I'm going to define first the get function. Okay, inside here, I'm going to define a function add that takes x and y as parameters, and then this will return x plus y. Okay, and finally, I'm going to return the add function. Okay, so here you can see that I am returning the function by name. I am not actually calling the function. So if I were to do add of 3 and 5, this will actually return the result of that call. But since I am doing just the name, I am just returning the name of that function, it is actually returning the function itself, not any value. Okay, now if we have our add function variable is going to be get function. So the variable now stores this add function. Okay, so the add function is stored in my variable. Okay, and now I can use that variable as a substitute for the function name. So I can say add function of 3 and 4, because I know that my add function is actually this add function that takes two parameters, right? So I can pass two parameters to my add function, and that should return the result 7. Okay, so let's try it out. I'm going to run this and I get the value 7. Okay, so you can see how we actually return a function itself. We store that function in a variable, and we use that variable in place of the function name to call the actual function. Okay, so it takes maybe a little bit of getting used to this kind of structure, but the main idea is that you can store functions in variables and you can return a function. Now, we can return a function, but we can also take a function as a parameter. Okay, we can pass the function to another function. So here is an example. We have our multiply function that takes two parameters and simply multiplies them and returns the result. Then I have another function called do that takes two parameters. This is simply a variable name. It doesn't really mean anything. I've put function here because the reader might get a feel of what we are expecting in that parameter, right? So this is basically a variable and another variable, two variables as parameters. And inside my do function, I simply say function, which is the parameter here, of a and 2 times a. So if we call this do function with my multiply function as a first parameter and a number 5, that should give us a result. So let's go ahead and try it out in our code. So I'm going to say def mul. So I'm multiplying x and y, and I am returning the x times y. Okay, so nothing special so far. However, def do will expect two parameters. I'm going to name the first one function, or func rather, and a. Okay, and I can print, so I can use the func variable name that I given it here to call the function mul, because I know I will be expecting a function here with two parameters. So I can say a and 2 times a. Okay, and now once we have that, we can actually call our do function with our multiplication function as a parameter, and let's say a number 5. So that should give me 5 multiplied by 2 multiplied by 5. That should give me 50, right? So let's go ahead and run this, and there we go. We get the 50 as a result. So we can see the two cases for our passing functions around. We have the returning of a function. We can store that function in a variable if we want to, or we can pass the multiplication. We can pass a function as a parameter to another function, right? So either return it or pass it as a parameter, and with the additional mention that we can store functions in variables. All right, so let's talk about Lambda functions. Now, Lambda functions are sometimes also called anonymous functions, and they are basically functions without a name. And we will see shortly why we might want to use those. So a Lambda function can be assigned to a variable and passed as an argument to another function. So even though a Lambda function doesn't really have a name, we can still refer to it by a variable name, okay? And then we can pass that variable to another function like we've seen in the previous video with other regular functions. And can have any number of arguments. So we can provide, like a regular function, we can provide any arguments we want. Now, the advantage of a Lambda function is that it is a single line. It is only one expression. So even though we can assign it to a variable, it's usually the case that we don't, right? So we only create it as kind of a throwaway function, a really quick way to perform some operation and to pass that operation onto another function. Okay, that is basically the purpose of a Lambda function. And it simply returns the result of that expression. So it has only one expression, one line of code, and it returns the result of that expression. So here is an example of how we might want to create a Lambda. We have the keyword Lambda, we have the arguments, okay, no parentheses, just the arguments here. We have a colon and an expression, okay, an expression that uses the arguments, and the return of this Lambda is the output of the expression. We can assign it to a variable if we want to. Like this practical example, we have the double is Lambda of x returns x times 2. Okay, so it simply doubles a number that it receives. And here we can simply print the double of 3. Okay, this is a kind of a standard way of calling a function. Even though we don't give the function a name, we assign it to a variable. So there's not too much advantage to doing it this way, except to kind of learn about how Lambdas work. So let's put this in practice and try it out in our editor. So I have the double variable that is a Lambda that takes an x parameter and returns x multiplied by 2. And then we can use that double variable in a print statement to say double of 3, and that should print out 6. There we go. So that is your first Lambda. That is how we create a Lambda function. Now, we have functions that take Lambda as arguments. So we call these functions higher order functions. We will see in a future video what that means. But for now, the main idea is that we have a function that takes another function as a parameter, right? So here we have our map function that takes a list, a function, and a list, right? So we can apply this function to our list. So inside the map function, we map each element with the function that is provided, right? So for num in the list, we print function of num. Okay, so here is an example of how we might do that. We have map, double, and 1, 2, 3. So let's try that out in our code. We already have the double Lambda here. So we can define our map of fun and list. Okay, and here we can say for num in list, we simply print fun of num. All right, so now that we have that, let's go ahead and call it. We're going to say double and list 1, 2, 3. So if we run it like this, we will simply get 2, 4, 6. So the doubling of each element. Now here is where the power of Lambdas come in. Instead of providing it in a variable, we can simply, let me just comment that out, we can simply create the lambda on the spot. Okay, so inside the function call, we can say lambda x returns x times 3, and then we provide the list 1, 2, 3. Okay, so I have just created a anonymous function, a kind of a throwaway function, a lambda function, and I have provided it to my map because I am no longer needing it after this function call. The only reason why I have this function is because the map requires it, right? So I am instantiating it here, creating it here, and then disregarding it. So if we run that, we get 3, 6, and 9, okay, which is kind of expected. So that is the main idea of lambdas. They are small throwaway functions that we can create, instantiate when we need to, and we don't really need them later on. Or at least if we don't need them later on, we don't need to store them in a variable. We can store them, but we don't necessarily need to, right? So that is the main idea of lambdas. So higher order functions are basically functions that take other functions as parameters. Okay, so in our example, our map function is a higher order function because it is expecting a function as the first parameter. All right, so let's talk about built-in functions. Now, built-in functions are functions that take a lambda as an argument and apply it to another variable, either to a list or a single variable, but the main idea is that they take a lambda and apply it to some parameter. So we have a few different built-in functions that are quite useful in our everyday programming. So we're going to go through them one by one. We're going to go through a few of them. And then at the end of the video, I'm going to give you a link where you can find the list of other built-in functions that we cannot cover here. So the first one that is really useful is the map function. So basically the map function applies a lambda to every element of an iterable, right? So we have already kind of implemented the map function ourselves in a previous exercise, but there is a built-in function called map that can do that job for us automatically. So here's how it works. We have a, let's say a map of a lambda. Let's say we are squaring the each element, and we apply that to some collection. So in our case, we are applying it to a set. So if we just do that, we will get a what we call a map type at the end, and we're converting that into a list and printing it out. So let's try it out in our code. Let's see how it works. We're going to have a result variable that's going to be a list of a map. Okay, so we're using the map built-in function. We're passing the lambda. So our lambda is going to be taking an x parameter and returning x multiplied by x, so x squared, right? So that is our lambda. And now we need an iterable. I'm going to provide a set. Let's say we have this set, just some random numbers. So if we go ahead and print out our result, okay, we will get the squares of those numbers that we provided, right? And we do that in the form of a list. So that is the map function. Now here's another example. Let's say we want to convert all the characters of a string to uppercase. Of course, we have the function .upper, but let's say we want to do that with a function just to practice our map function, right? So we have our map function. We take each character individually and call .upper, and then we pass the string or the iterable that we want to apply it to. Now, again, the map function will give us a map type, and in order to convert that to a string, we will do empty string.join, and that will convert that into a string for us, and we will print that result. So let's go try it out in our code. I'm going to say res equals. So first of all, before we convert it to a string, I want to just show you what the actual map function gives us. So I'm going to say map lambda. I have a character char.upper. Okay, so that is our lambda. Now let's provide a string here. hello Johnny. Okay, so we have our res. I just want to print out the type of the res output. Okay, so here we can see that we get a map type. So if we want to convert that to a string, we're going to say print empty string.join, and here we're going to provide our res. Okay, so we're converting that to a string and we're printing it out. And there we go. We have our capitalized string, hello Johnny. So that is how the map function works. And I invite you to try your own ideas, your own exercises to practice the map function. Next up, we have the filter. Now, again, we've put this in practice ourselves before, but the filter function just is kind of a shortcut for us, right? So it will basically return all the elements that pass the filter. So here is an example. We have our filter function that takes a lambda. In our case, we are simply checking whether a number is even, okay? And we are passing also a list of integers, right? So the filter will basically give us a true or false. And if the number is even, then it will go on, it will pass the filter. If not, then it will not pass, right? So then we are converting it into a list and printing it out. So here we only get our even numbers. So let's go ahead and try that in our code. We're going to say res equals filter. Now we need a lambda. So the lambda needs to return a true or false value. So I'm going to say lambda takes an x parameter and it returns x mod 2 equals 0. So that is my lambda that will return true or false. And then I need to pass a list of integers. I'm just going to put some random integers here. There we go. All right, so we have our filter. Now we also need to convert that filter into a list, right? Because if we do just print res just like that, then we will get a filter object. Okay, so we need to say list of filter. Okay, let's go ahead and run that. So there we go. We have our list of even numbers 6, 4, 6, 4, 8, and 2. Okay, so that is how the filter function works. Now here are a few more functions. Now these functions that I'm going to show you now don't necessarily take a lambda, but they are built-in functions, and I thought it's quite interesting to see how these ones work as well. So for example, we have our sum functions, which simply returns the sum of the elements of the iterator that we pass to it. Okay, so here is an example. We have a sum of a list. Okay, 1, 2, 3, 4, 5. The sum of those will equal 15. So quite simple. We are printing the sum of, let's say, a list 1, 2, 3, 4, and 5, and that should give us 15. Right? So there is no lambda being passed here because we are not applying lambda to the elements of this collection, but it's an interesting function that I thought it's also a built-in function, so why not study it as well? And there are a couple more that I want to show you, which are the any and the all functions, right? So these ones return true if any of the elements are true, and this one if all the elements are true, right? So here is an example. We have any of this collection. So this will give us the truthiness, the true value of these variables. So 0 is going to be false, empty string is going to be false, but 1 is going to be true. So any of these will return true because we have at least one that is true. So let's try it out. I'm going to print any of 0, 0j, complex number, or 1. Okay, so let's go ahead and run that. That will give us true because we have at least one element that is true. But we also have the function all, which requires all the elements to be true in order to return true. So let's try that out as well. We're going to say print all of this collection 0, 0j, and 1. So that should return false because there are some false elements here, and that will return false. There we go. So we have our false. Now, of course, there are a bit more built-in functions that you can use in your code. I didn't want to cover too many here because I don't want to overwhelm you with those, but you can find them all in this link that I have put here, and it is attached also to the to this lecture. So have a look at those, try them out, practice them as you will, and yeah, just use them whenever whenever you need them in your code.